Good morning, everybody. Thank you for joining our webinar today, Window Installation, Waterproofing, and Airtightness. My name is Chris. I am the marketing account here for Rothoblast in North America, United States, and Canada. And I'm glad that you're here with us today. We have a special guest, engineer Matteo, giving this presentation for you today. And at the end, as always, we'll leave some time for Q&A. If you do have any questions throughout the presentation, please just at the top of your screen, if you're on a computer, click the Q&A tab, drop your question in there. If you're on a phone, there's three dots at the bottom right hand of your screen, and then you can click that menu open, find the Q&A, and send your questions there. So without further ado, Matteo, the floor is yours.
Thank you very much, Chris. Hello, everybody. Thank you for joining this seminar. I'll start by introducing myself, as you've done, Chris. So I'm Matteo Androttola. I'm an engineer. I'm actually a timber structure engineer. I live in Italy and I work for Rotoblas. In particular, I take care of the Roto School, which is a part of Rotoblas who's taking care of the trainings. So we do roughly 120 training per year. Some of them webinars like this, some others are in person. If you haven't been to any of those at the moment, please check them out. You can all find them online on the webpage of Rotoblas. So let's go straight to the topic of today. We are going to talk about window installation, waterproofing, and airtightness. First of all, why have we brought up this content to you guys? Maybe some of you are engineers, designers, architects, and you've been all designing this, timber structures or other types of structures. And I was once a technical consultant for Rotoblas, and I've seen that the most issues come from the waterproofing and airtightness and the detailing of some part of the structure, like for instance, the connection to the ground, the window profiles, and so on and so forth. And therefore, this is why we've chosen to bring up this topic here to avoid mainly some of the issues which are most common. We will start a little bit by introducing what is airtightness and waterproofing. It is actually, in my opinion, very easy to understand why it's important to have airtightness why it's important to waterproof the buildings, because it's easy to understand that water can damage your structure. It doesn't matter if the structure is made of timber or other materials, but it's obvious that water can damage the inside of your building. It's not just as easy to understand why exactly it's important to provide airtightness to your building. And this is part of the presentation of today. It's a little bit the basis that we need then to understand also the window installation, the correct window installation. So let's try to understand together why airtightness, what is airtightness in the first place, and why airtightness is so important in buildings. So first of all, airtightness, it's important because you avoid having cold air coming into your building, and this is obviously important for the cold bridge, but cold bridge is just one issue that you might have. If you're lowering the temperature inside of the buildup of your structure, there's also another risk, which is condensation risk. And we will see some examples and pictures of it, especially related to window details throughout this presentation. So this is one thing, but there's also another issue related to not correct airtightness of buildings. This is the acoustic. In fact, probably you've experienced before, if you step into a building which is not properly insulated for airtightness, for example, you hear the traffic jam on the outside of it, or you will definitely feel that it's not properly insulated for the acoustic. So this is also a very, very important part. So how do we do then this airtightness layer? It's easy to understand that the waterproofing layer is on the outside, is the one that you can see here in blue, here on the outskirt of the building. And the airtightness layer is the one that we've inserted in red onto the inside. If you are a designer, and I think most of you are designers following this webinar. You need to, every time you do your drawings of the building, it's important to draw these two lines. One being the airtightness line on the inside. You can draw it, for example, in red. We'll see again some examples throughout this presentation, and also the waterproofing line on the outside, thinking all of the details. Actually, I've been working for many years as a structural engineer, and in all the designs that I've seen in my career, let's say, I've seen many details for the structural part, so connections and so on and so forth. But usually there are not very many details, you know, into the drawings for the airtightness and for the waterproofing actually. And this is why sometimes there are issues, because you're basically relying on the people doing the installation job. If they're good, they will do then even without proper drawings and proper detailing, they will do a good job. Otherwise, if they're not specialized and maybe they are doing it for, they're not very good at it and not very experienced, you will find out that your house has some durability issues throughout the years. Another thing that we haven't discussed is the wind tightness layer. This is just as important. A wind tightness layer obviously is to avoid the wind coming in. So again, as we said before, is to avoid the cold bridge. But just as important is the fact that you should, as we said before, avoid that the cold bridge into the initial layers of the insulation. If you're lowering the temperature, the colder the temperature, the more risk you have for potential condensation onto the inside. So another question that you might have right now, what materials can I use to do the air tightness layer, for example, or the wind tightness layer? There are many materials that you can use. For example, plaster is a wind tight and airtight material. Also OSB, OSB oriented strand board is full of glue and therefore it's 100% airtight. I mean, the panel itself is, but keep in mind that every time you have a discontinuity, you have a gap, basically, there's potential air coming in. So you have to seal all of the gaps that are potentially happening. What about CLT, cross-laminated timber? Cross-laminated timber, it depends is the right answer for this question. It depends. Sometimes it is airtight, sometimes not. And usually this is related to the number of layers that we have in our panel. Because again, wood is a material which is very breathable. And therefore, wood by itself, it is not airtight. Because you know that it has this grain on the inside, which is hollow basically, and therefore air can pass through there. And so what is that makes it airtight? It's actually the glue that is, in between a layer and the other, the one layer of CLT and the other. So you can immediately understand that the more layers you have in your panel, the more airtight the CLT panel is in the first place. So basically, the common rule is the following. If you have 3-layer CLT, this is not airtight unless it's differently specified by the producer. If you have 5 layers CLT or more layers than 5, you will have no problem. So usually, even without certification, you have an airtight material. Then obviously, last but not least, we have membranes, which are always airtight. Every single membrane is waterproof and airtight. This is a common rule. Obviously, it's like buying a jacket. So if you buy a jacket for the outdoor, they might be, all waterproof, but there are some that are more waterproof than others. This is also a general rule which is always correct. We will see how to, in this presentation in particular, we'll be not concentrating too much on membranes design and build-up design, because it's not the main topic. We have to talk about the window detail more, but there will be other opportunities to go through it. We do it commonly in our courses actually. Just another thing which is important, another concept which is important to grasp before we go on with our detailing of the windows. It's the condensation risk. Condensation risk is important to understand before we go to the window details, because it's a common, very common failure mode that you have in Windows, especially. So how does it work in general case? You see that in here we do a little bit of we simplify the theory very much, because this is not really a physics lesson, so we don't want to do a physics lesson right now. It's just about understanding the concept. So follow with me here. You see that we have our build up, our wall of the house. On the inside of our building, we have these vapor molecules. You see that there's a lot of vapor molecules, because basically there might be on the inside of your house, there might be toilets, bathrooms, or people breathing and producing this vapor. And you see that especially in the winter, you have on the outside, obviously the US is very, very big country, and therefore you have different climates as well. But let's say you're on a dry and cold part of the US, and therefore you see that you have very low quantity of vapor molecules on the outside. So as a the nature always tends to equilibrium, and therefore all the vapor molecules on the inside would tend to escape to go outside. And this is a good thing by itself. It's not a bad thing that the vapor molecules are getting out of your building. The only thing is that while they do that, you have a potential condensation risk inside of the buildup of your house. So this is why, in the first place, you have to design the buildups so that you are not risking too much, this condensation risk. And why exactly condensation happens? This is again another very simplified explanation. You see that at a certain temperature, when it's hot, air is a gas that varies the volume depending on the temperature. So basically, when you have a hot when the air is hot, it can contain inside of it a lot of vapor molecules. You see that just by varying here the the temperature, you see that the volume of air is reducing, and therefore you get to a point in which you see that we are not varying at all the amount of vapor that you have into the air. We're just reducing the temperature. You get to a certain point in which the vapor molecules cannot be contained anymore into the air, and this is the point in which condensation happens. That's where you start seeing the droplets. Remember that condensation does not only happen with very, very low temperatures. Obviously, if you are out having a cold beer in a hot day, you will see condensation on the sides of the glass. But it's always remember though that you see condensation when you're in a sauna with a glass door, for instance, and in that case you see exactly the same condensation, even if the temperature is extremely hot. So basically, there are two variables. The first one, as we understood, is the temperature that you have. And the second one is the amount of vapor molecules. So if you have a lot of vapor molecules, even with quite hot air, condensation might happen. Why am I telling you this? Because even with normal with normal characteristics with of internal temperature and amount of vapor and outside temperature, even at 13 degrees, you start having condensation risk. This is 13 degrees Celsius, meaning here you guys have to do the if you're used to other units. Unfortunately, myself being European, sometimes, But let's go on. Now finally going to the window details. So window details are, if we've seen before that the wall in particular, a wall can be challenging already by itself. And if you think about it, it's quite a simple element. Imagine how complex it can be to install and to design a window detail in the right way, because you have all of the same issues. So wind tightness, insulation, condensation risk, air tightness, even in those kind of details of the window. So definitely it's a harder task to do. So this is a picture, for example, that I've taken from a consultancy that I received once. So you see that the window, it's on the side here. Everything, it's obviously a timber structure. Everything seems very well done with these beautiful colors and so on and so forth. But actually, there's an issue. So the drawing is good, but the design is not just as good. So you see that you see immediately that there's an issue of where I'm pointing here with my cursor here. There's an issue of cold bridge. What does that mean? Cold bridge is the first thing that you have to avoid while you're doing a design of a window. And this is because even if you do every other thing in a perfect way, so you do the airtightness in a perfect way, you waterproof everything in a perfect way, but you have cold bridge somewhere in your details, meaning basically cold bridge means that this part here is colder than the rest of the surface, basically. You are in a big risk of interstitial or superficial condensation. Because we said it before, we have two variables. The first variable being the temperature. So if you're lowering the temperature, the condensation risk goes high, basically. So you see here, I've done my testing here. You see that from these thermal lines, you see immediately that there's a colder temperature here, right in the corner where I'm showing where I'm pointing out to you. So again, this is the thing that you're risking if you don't do things in the right way. And especially, let's look at the window detail on the right. And also, it's something interesting when you see an issue is to do like a study of the issue. And you might ask yourself, what can I study here? It's just a window corner with some mold on it, so there's nothing to study really here. But it's interesting to notice that the amount of mold is maximum into the corner right here. And as you go towards the center of the window, you see that the amount of mold is decreasing. So this tells you already about the potential issues that are related to this mold problem. Actually, if you end up with something like that in your house, your wife would ask you to solve the issue. So just to test you out, guys, could you write in the comments so that I see if you guys are actually active and if you're actually listening? Can you write in the comments how you think you can solve this problem here? So again, let's repeat the question. You're at home and you have in your toilet, you have this issue, and your wife or your husband is asking you, please solve it. Tell me a way how to solve this issue. So please write it in the comment while I talk. And let's try to understand it together. If it would be a cold bridge, you would have the same temperature throughout all of the perimeter of the window. And that means the amount of mold would potentially be the same on the whole perimeter. In this case, you see that there's this variation that we discussed, that we explained before. And this is because it's an airtight problem. So what does that actually mean? Airtight problem means that the corner detail was not done in the right way, meaning you have some cold air coming inside of the building, exactly where the corner of the window is. This is a super, super common mistake. Just to understand how common it is as a mistake, I will bring to you this example. Here in the headquarters of Rotoblas, which is based in the Dolomites, we do also some practical, teaching and training for the window assembly. So we divide people in groups, and they have to do a little corner of a window. They have to tape it. They have to first actually design it, detail it in the right way, and then go down and do like the taping, do place the profiles in the right way, and so on and so forth. And even if they've just follow the lesson, even if they know exactly what the issues might be, I go and I pass through the groups, and I see anyway a lot of issues in the corner. This is because when you're putting a profile like a tape on the corner, it's actually easy to leave a gap in that location. So I left you a few minutes to answer the question. Let's see if somebody actually wrote something. No, actually not.
No, I do. They wrote it into the Q&A section
In the
there.
Q&A,
So,
yeah, thanks.
yep. One of the answers I see is add insulation to take away the cold zone.
Okay,
And
let's
then the,
comment this one first. That's an interesting one. So, add insulation to take away the cold zone. This could have been yes, an answer, but in this case, I don't think the issue here is the cold bridge, because you see that the mold is not continuous. So that would be a potential solution, but not for this case in particular. Let's see the second one, Chris. You want to read it out?
yep. And then the second
Uh,
one says depends on multiple factors to solve. If I heard correct that it's in the bathroom, make sure the fan is on when you shower, it will reduce.
In fact, actually, that's another smart answer, and this is actually was to test you guys to see what is the general know-how here between the. Thank you very much for the people who wrote down something, by the way. And this is also correct. In fact, my grandmother used to tell me, any time you finish showering, please open up the bathroom window. And it's correct. We said it's the bathroom. And this is a very, very important rule. If you have a fan, leave it on, and this is all correct. But these are things that you can do to prevent like this kind of issue, uh, of happening. In this case, if you want to solve it, I'll tell you what I think the right solution is. So you have to take away, unfortunately, this part of plaster. So take away completely the plaster. Unfortunately, you have to partially break it. Once you have cleaned up everything, you've taken away that layer of plaster, you can retape the all around the window in the right way. By the way, if you look close enough here, you see that there was already a sort of, I'm pointing it out right now, you see that there was tape or something like that. I don't know if it's tape or a membrane or something which is sticking out a little bit. So, but you see that it's not continuous into the corner. So what you have to do is starting from the bottom, which is always important. Even like if you're doing waterproofing, you always start from the bottom. This is exactly the same concept as tiles, so that water or air cannot get in. You start by placing a first layer of tape. Then you do the corner detail. Unfortunately, it's not a practical lesson here, but if you open up the catalog, there's a way by cutting and bending a little piece of tape to do the corner in the right way. And then you continue with the vertical side of the window. And after you've finished the whole perimeter of the window in this case, if you've chosen, and in this case, you have to make sure you do, if you've chosen a material which is plasterable on the top, you can just replaster on top of it. Obviously, it's a little bit a hassle, but this is the way you should solve it if you have something like that. This is the real way to solve it to avoid it from happening again. The design is also an important thing. If you are a designer and you want to avoid the issue in the first place, you can basically use this kind of graphs. If you don't have any any softwares to do this kind of things, you can use a software which is freely available online, and maybe we'll link it afterwards. It's called Ubacus, and you can insert also rotoglass materials in it and make sure that everything works. Actually, let's go on another interesting thing that it's telling you why it's so important to do the designing into the right way. And with design, I mean the design of the build-up and the window design. Check out these numbers over here. With 1% of water absorption into the insulation, you are increasing the lambda by 30%. What does that actually mean? That means that you're losing basically a third of your potential insulation properties, just by adding 1% to the insulation. And this is because insulation is created, it works because it has a lot of air gaps in between the insulation itself. And therefore, if you're replacing those air gaps with water, you end up, with losing a lot of your potential. So finally, let's go to the last but not least, let's go to the windows. I would like to show you some examples because I'm sorry that I've taken away half of the presentation with the theoretical concepts, but I think, and that's an important part. I think most of the people who are following here are potentially already used to working with Windows, and so you might have seen a lot of case studies already. But let's go through some case study together also. So you know that there are very many types of windows, and not only the window itself, but there are very many ways to install the windows. You know, it's you can will see many applications, possibilities that you have. I'm not saying that one is correct, the other one is not. They are just different ones. And the first thing that you have to see is what kind of material you have. You can have PVC, you can have wood, wood and aluminum, PVC and aluminum alone, and so on and so forth. Instead of having a small window, you can also have a curtain wall, like the one I'm showing you here in the picture. So a very, very big structural window, like the one we see on the image. And for these kind of things, they are also it's also more difficult because it's nothing standardized. And I would like, since you guys are all from the US and from around America, I wanted to also bring to you all the typical, types of windows that we have in the world. I brought to you some of the European examples with, you just change country, you go a few hundred kilometers in one direction, and the architecture just changes completely. So imagine how difficult it is, especially here in Europe. So, but just to draw a line with the potential things that you have into the window design, let's go through two different types of installation. One of them is with a subframe. So you see that the subframe is without the subframe. So you have only this part here that I'm pointing out, which is the fixed frame of the window. and you have the moving part of the window, which is this other one. So that's basically it. And we will see what kind of details you have. You see that you have the red one here towards the inside. You have another one on in the middle, and another one towards the inside. We'll go through there in a second. You see that we have windows with a subframe. A subframe means that you have basically, before placing the window itself, you have already something which is, which is usually a piece of wood, can be shaped like in this case, like in the example that I brought to you, and it's just a help for positioning but mainly for making the installation, the waterproofing and airtightness installation easier. We'll go to there in a second, but basically the advantages that you have with a subframe are the fact that even if you don't have the windows on site, because you know how it works on site, it's very easy to have a potential, delay, and potentially the window should arrive on site 1 month and is actually arriving the next. So sometimes you easily have 1 month of delay into the installation of the windows. So in this case, a subframe is allowing you to finalize and finish all of your taping before the windows are actually on the construction site. That means, just to make things a little bit more clear, I would choose to use a subframe in a timber structure in the following cases. First of all, you know that timber is a very precise material, and therefore we wouldn't need actually a subframe for tolerance, because you know that with masonry, that's in many cases it's quite common to use a subframe to just make sure the tolerance is the right one. But if you have timber, everything is cut with CNC machineries, or it's cut in a very precise way anyway, and you don't need that for tolerance. So you really need the subframe for finalizing your detailing of waterproofing and airtightness before the window arrives. That means you use it just if you're not the provider, for example, of the windows. If you're unsure how long the windows is going to take to arrive on site, if you don't want to risk that, and so on and so forth. Otherwise, yeah, you see easier install and easier connections, completion of details without installing the window frame, waterproofing window sill without installing the window frame, and so on and so forth. You see that it's making your life easier. Actually, I brought this picture to you guys, and this is another system that you might have seen before. Nowadays, there's many times everything is pre-done, prefabricated, and also the window detail is prefabricated. And this is something that I want to point out immediately, because a lot of people tell me, so I don't need to know exactly where to place the tapes and profiles before I buy these ready-made solutions here. But actually, when you're choosing which one of these solutions is the correct one, you need to know the basics. How do you know if one's ready-made solution is good or not? This is why we are doing this kind of things. So we're not going too much into this kind of details, because there are so many of those that we'll never finish. Let's go into the general characteristics of the window. You've seen it already by the few examples that I've shown you, that there are 3 layers of protection, and this is something that in Rotoglass we always try to push. So there's starting from the outside, you see it here in blue, you have your first protection layer, which is exactly the one that we've seen in the first images. Remember when we saw the picture of the house? we have the wind tightness layer on the outside. So that's basically to avoid wind to go in, but it's also a crucial point for the waterproofing. So it's also there to avoid, water getting into your building, which for durability and also for your well-being and for the well-being of the structure is critical. So we have also then a second, a second layer, which is always it always needs to be there basically, and it's the thermoacoustic insulation. This one usually it's not a tape. This is an expandable profile. You can use basically an expandable profile like expand band from Rotoblas, or you can use foam. Actually, myself, I would prefer the expandable profile because you're sure that you have it, evenly placed around the whole profile, and you can prove to your customers, to whoever is checking, that you've done things in the right way, and yourself, you can be sure to have done things by the book. With foam, you'll never know if the foam is enough, if you've placed the foam all around the profile of the window, or if not. This is why, I tend to prefer, expandable profiles. Then on the inside, you have a third layer of protection. And I repeat it again, these three layers needs always to be there every time you have a gap, discontinuity. You need to have all of these three layers to protect the gap. So just to make it even more clear, if you have a counter frame, so you have your structure, you have your counter frame on top of it, means you have a gap like just beneath it, and you have the fixed frame of the window, meaning you have another second gap. You need to have these three same protection layers in both of the gaps. That's also very important. So also the positioning of the window can vary completely. We have a positioning which could be this one. So a window which is placed on the outside of the wall. So like parallel as a as a continuity of the insulation layer. In this case, this is good. It's you see that they've placed here insulation on top of the window to avoid potential condensation, to avoid, sorry, potential cold bridge. And you see though that the thickness of this insulation is lower than the overall thickness that you have onto your wall. So make sure you use a better insulation to, avoid cold bridge, totally avoid cold bridge. Otherwise, if you do something like this, if you stop your insulation before you see that you have the cold bridge. A better idea is to, set back a little bit the window, like I'm showing you right now in the picture, and it's better to place the insulation on top of the window fixed frame. This is to avoid cold bridge again. So this is way more efficient, and you can, by the way, use potentially the same insulation, keeping the same thickness. So this is actually a type of solution that I like very much, and because of the simplicity, and this is easy to do. This is used, by the way, many times in the north of Europe, also in the north of Italy, where I'm speaking from at the minute. So you see that usually the doors and windows are opening on the inside, and you have quite a big window sill onto the inside that you can use to sit on, or to do whatever you want, to place stuff on, or so on and so forth. So again, you can potentially place the window also closer to the bottom part, which is, again, this is the internal part. In this case, though, you have to pay even more attention. in bending down, you see in placing insulation on top of the corner in here. Otherwise, cold bridge would become a very big problem, leading to condensation, and we've seen what that means in the first place. That's a common design. You can put it in the middle. You're left with two seals equally sized on the inside and on the outside. Very typical in the Italian culture, in the Asian houses, like the one I'm showing you guys. See, by the way, every time I open up one of these drawing for you guys, you see that the layers that we are discussing are always there. So you see that in this case we have, and I'm pointing it right now, I'm pointing it to you guys right now, this red part, which is a tape, and you see that this one in particular is continuous with with what seems to be the OSB board on the inside of the timber frame. So you see that this is continuous. Remember, though, that the timber frame itself is it's airtight, so that's perfectly correct. The only thing that you have to do is taping also around the gaps that you have in between the boards of the OSB. In here, you don't see it very well, but we'll see better zoom in. Later on, you have expandable band in here as well, and you have a tape on the inside, which is not only making sure that the wind tightness is correct, is done correctly. You see that it's sealing that gap over there, but you're using, in this case, this protect band, it would be, or something, or ground band or something similar. You're using it also to, waterproof the window, the external window sill that you see right now. In this case, it's done of stone, but it could be anything also on the outside. Obviously, you can always put also the window on the bottom part, and actually this type of detail is used many times to open up completely the windows towards the inside. If you live in very hot countries, this could be an interesting detail also. So you see, just to sum up here everything in the last few minutes that we have together, you see all the three example, in the same slide. One other detail that I wanted to discuss with you guys is when you have a window box. So whenever you have some shading system like the one I'm showing to you right now, and in this case it's a round one, and which is coming down here. This case, obviously, it's important to have insulation onto this part. You see that potentially you can have a little bit, in this design, you have a little bit of cold bridge going up through the detail in here. So it would be better to have something different. So this one, I don't like it so much. You see immediately potential issues coming here, interstitial condensation, and so on and so forth. Obviously, you need to have a fixing point, as you see here in the image, but you need also to make sure that this is also solved on an insulation point of view. Otherwise, you end up with issues. In fact, you can place, for instance, here a structural insulation and lower a little bit the detail, so that you don't have problems. And on the rest of the detail, you can place, for example, XPS or other insulation material according to your needs, so that you don't have issues at all. And obviously, you assess a little bit the element here for the mosquitoes, and so that you can fix it directly to the structural insulation. You have also other case studies with this is another system which is not round, but it's has a different shape, has different shading system. And in this case, you see that the insulation is done already by the producer of the box, and this is a very good one. So even when you're choosing these kind of things, always make sure in your details that the insulation is continuous and it goes all the way around your detail. And this is the first rule that you need to have. Practical examples, and we are getting very close to the end and to our to our question and answer part. You see that we have an easy, for air tightness, we have uh, more than one product that you can choose. I just wanted to point out some of the ones that you can potentially be using. We have also insulation for the thermoacoustic insulation, the one in the central part, and products that you can also use for wind tightness and just as well for the the waterproofing also. So just I would like just to point out some of the ones that are potentially more interesting. So seal band is interesting because it's a tape made of paper, so it's very easy to rip it and with just using your bare hands, and so that's a very simple one. Don't use it on the outside because it's paper based and it wouldn't work. If you want to use something on the outside also, you can potentially use FlexiBand. This one has the main characteristics of having a lot of glue. Having a lot of glue is very good. The FlexiBand, therefore, is one of the most interesting products, but it can be not the best choice if you have a lot of heat, for example. So if you have a very, very hot temperature and a lot of UV rays, and you're using then on the outside, you see in fact that I placed the facade band UV or flexiband UV, or something which it has a little bit less glue, meaning that the glue is not softening so much with hot temperatures, and that can be better used on the outside. Other interesting ones are also smart band. This is a butyl based band, so it's very interesting because it's super stretchy, and you can also use it. You can use it on corners, for instance, and it's self-sealing. So that means if you go through it with a screw, it would automatically close the holes that you're doing. I told you that for the thermoacoustic insulation, you have, again, um, very many options. You have foam, you have bands, but the one that I like the most is the expand band. In my case scenario, I'm used to use something like that. It's a tape. It's not a tape. It's a profile that is expanding with humidity and time, basically. So when you place it, it's off. It's a flat piece of the material. After a while, you see it growing more and more and more. And this is basically the one that I was mentioning to you before, which is closing every gap. On the outside, for waterproofing and for the wind tightness, you use, again, tapes are again the most common solution. Just make sure you're using a tape which is UV resistant if it's left exposed to the weather for some time before being completely concealed. Otherwise, remember that UV are a very, very big issue all the time because they are completely destroying, the products for this kind of products if you're not using the right one. And just remember again here, if you're using something like a tape like the FlexiBand UV or the facade band, you in this case you are not allowed to plaster on top of it because the plaster will not be fixed correctly on the top. But if you want to plaster on top, you can use Protect, for instance, because this has it has a non-woven fabric on the external bit, and you can easily plaster or glue even on top of it without problems. And this would be also a thick butyl material that we used before also to protect the seal. You see this blue line, for example, you usually use Protect, for instance, for these smaller lines. You use tapes, for example, just to give you examples. So you see, let's zoom in a little bit more on this detail right here. So you see that you have on the inside, you have the tape, which is connecting the OSB to the window. So in this case, you have a continuity, everything works. You see that in this case, you have two expand band, the ones in yellow, and let's see, window band or frame band or expand band, they're all okay. For the red ones, you can use anything for air tightness. You see seal band, flexi band, or even easy band. You can place here also a little bit, you see on the top here, just to make sure you have a little bit of extra protection, and it's also beautiful to see. You can put a little bit of seal. It's basically a profile to close any gap, MS seal on the top. And so yes, just you see you have this extra protection right there. And here on the inside, on the outside, sorry, you place the Protect, because you see that you have to glue on top of it this stone piece, and therefore you need something with a little bit of non-woven fabric on the top. Also remember to bend it also at least 10 inches on the top, otherwise you end up with problems. And the expand band here in the middle is really important. It's also good to place a little bit of expand here on the side, and this is to avoid cracking in this location, which is usually occurring otherwise. Uh, Always remember the dripping element in here for your elements, and here basically the element has this net on the bottom. Sorry, I forgot to translate this part here. I'll make sure I translate it when I send it to you. And you can place a little bit of MS seal here and there. This is not the part which is, MS seal. If it dries up, you can if it loses a little bit of elasticity, it can throughout time it needs to be replaced. Tape is a better option whenever you can use it, because it's more durable. But you can use the seal just to make sure you close extra gaps, and also for finishing the elements. Otherwise, if seal is your only option, which sometimes it is, just make sure that you are replacing it. You're replacing the seal every so often. Thank you very much for your attention. And now it's time for the question and answer, if there's any. So, Chris, I give the microphone back to you.
Thank you, Matteo. Currently at the time, I don't see any questions in the Q&A. So as I'm kind of doing this little bit of wrap up, if you do have any questions, please feel free to put them in there. If we don't have a chance to see them come through before we end, we will make sure to send you an email after the fact. If you do have any questions in the next hour, day, week, month, please feel free to reach out. You can see Matteo's email is here on the screen. You can also reach out directly to eng.na@rothoblast.com as well. As always, we do have more webinars coming up next week in particular. If you go onto our Eventbrite page where you registered for this one, you'll see we have one on solutions for safety. And then later this week, we will also be releasing our September lineup of webinars. So with that, I just want to pass along one note here. Matteo, we got to thank you for the presentation. So thanks again. not just from me, but from our guest today. And we look forward to seeing everybody again in the future.
Thank you very much, guys. It was a pleasure. I'll see you very, very soon in on webinars or